Section 6.3 Properties of Trigonometric Functions. In the previous section, we introduced the 6 trigonometric functions, and in this section, we're going to look at their properties and how to use them. The first thing is we can recall from before, recall if point P with coordinates x, y is given, is a point on the unit circle corresponding to angle theta. What we had from previous section, sine theta was y, cosine theta was x, tan theta y over x, cotan theta x over y, secant theta 1 over x, and cosecant theta is 1 over y, provided that denominators are not 0. So what we are going to look at here is back to the unit circle. 0, 90 degrees or pi over 2 radians, 180 degrees or pi radians, 270 degrees or 3 pi over 2 radians, and then that goes to 360, which is 2 pi radians. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. We are going to look at the sign of those 6 trigonometric functions in each quadrant. What is it positive? What is it negative? So let's look in the first quadrant. I'm going to pick the point P here, x, y, in the first quadrant. Remember, this is the origin. And this is kind of like x-axis, y-axis. In that quadrant, we know that x, if I plot any point in that quadrant, both x and y are going to be positive. So this means in that quadrant, both sine and cosine are positive, because sine is y and cosine is x. So both of these are positive in the first quadrant. And notice how the rest of the functions, the other trig functions, are written in terms of x and y. So this means all the trigonometric functions are positive in here. So while we're working in this, all the trigonometric functions are positive. Second quadrant, if I pick the point P here, any point you plot on the plane to the left of the origin, the x is going to be negative and y is going to be positive. So negative, positive. So imagine you're plotting the point -3, 2. That would go in the second quadrant. So this means in the second quadrant, x is negative. Well, this means cosine is negative. Sine is positive. So I have sine of theta is going to be positive here. And so this is positive. Which one also has to deal only with y? 1 over y, which is cosecant. So these two functions are positive in the second quadrant, and the rest are negative. Look in the third quadrant, pick a point P here, x, y. In this quadrant, x is negative, y is negative. Well, this means both sine and cosine are negative. But if I have this negative and this negative, their division would be positive. In that quadrant, tangent theta is positive, and the same for cotan. And the rest are negative. In the last quadrant, quadrant 4, if you pick a point x, y, x is positive, y negative. This means if x is positive, means cosine is positive. So in here, cosine theta is positive, and cosine has to do with these two corresponds to each other. So secant also positive. Positive, 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 positive. And some students, they try to memorize it. They take the first letter of those trig functions, and they say all students take calculus. So all means all the functions are positive. Students, S for sine, T tangent, C cosine. All students take calculus. So that helps you to find where each function, the sign of each function in each quadrant, is it positive or negative. Notice while we were doing the signing for the trig functions, you see I said that cosine and secant, they correspond to each other, and sine and cosecant correspond to each other. So sine and cosecant correspond, and these two are reciprocal of each other. So that motivates us to introduce and say that cosecant theta is 1 over sine theta. It's 1 over y, and y is sine theta. Secant theta is 1 over x, but x is cosine theta. And cotangent theta is 1 over tangent theta. They are reciprocal. And since they are reciprocal, we call them reciprocal identities. Those are reciprocal identities. So if you know sine, you can get cosecant, and vice versa. You know cosine, you can get secant, and vice versa. Tan, you can get cotan, vice versa. On the top of this, if we look back at tangent, it's defined as y over x. So tangent theta, it's y over x. But y, what is y? Y is sine theta. X is cosine. So that tells us that tangent theta is sine theta over cosine theta. Very important. And the cotangent, because that's the reciprocal, so it's cosine theta over sine theta. Those are called quotient identities. As we learn more and more trig, we're going to end up building more and more identities. And to practice now on the signs that we introduced earlier, in which quadrant each one is positive and negative, let's say name the quadrant in which the angle theta lies. Let's say part A, if sine theta given to us as 3/5 and cosine theta is negative 4/5. So we need to look for the quadrant where sine is positive and cosine is negative. So let's see. In the first quadrant, all of them are positive. In the second quadrant, sine is positive and cosine is negative. And that's what it is. Sine is positive here, so it's positive, and that's negative. So that's a positive. So then this is quadrant 2. So theta is located in quadrant 2. Another example, what about sine theta is negative root 3 over 2? And cosine theta is negative 1/2. In which quadrant both of them are negative? Well, it's not in the first, not in the second because sine is positive, not in the fourth because cosine is positive. This means it's the third quadrant. So that's quadrant 3. So theta lies in quadrant 3. What can be other applications to this? Let's say given sine theta root 3 over 2, cosine theta 1/2. We need to find the exact value of each of the remaining trigonometric functions of theta. So how do we start finding this? They give us sine theta and cosine theta. Remember, we said that sine theta is always y in this case, if we are working on the unit circle. Cosine theta is x. Is it true here that this is really on the unit circle? We can check if we like to do so. So we find x squared plus y squared and see if we get 1 or not. Well, x is 1/2 squared. Y is root 3 over 2 squared. That gives us 1/4, and that gives us 3 over 4. That's 4 over 4, which is 1. So that confirms we are working on the unit circle. So to find the rest of them is going to be very simple here, because we found sine theta is root 3 over 2, which is y. Y is root 3 over 2, and x is 1/2. So what is x? What is tangent now? Tangent we define as y over x. So it's root 3 over 2 over 1/2. The 1/2, the 2's cancelled. That gives me square root of 3. Cotangent theta is x over y. So it's a 1/2 over square root of 3 over 2. The 2 cancel. So that gives us 1 over square root of 3. Always rationalize. How do I find cosecant? Cosecant is 1 over y. Y is root 3 over 2. So that's a division sign. 1, we switch it to multiplication and flip the fraction. Then rationalize. Secant theta, 1 over x, 1 over 1/2. That's a 2. Notice something about the signs. Everything I got was positive. Well, because both sine and cosine are positive, the only quadrant, here sine is positive, but cosine is not. Here cosine positive, but sine is not. Here both of them are negative, so the only place is the first quadrant. And in the first quadrant, all the trigonometric functions have positive values. And that's what we got. Now what about if they ask us, so I'm gonna say the same means find all the values of the trigonometric functions for this problem. If they give us sine theta is negative 5 over 13, theta in quadrant 3. So they only give us one trigonometric function and they ask us to find the remaining. This can be more difficult because sine, having only sine with us, we only know probably y, we don't know x. So what do we do in this case? We introduce some trigonometric functions here to help us with this. Note that recall from before that x squared plus y squared is 1. Remember, this is cosine squared theta, this is sine. So that tells me sine squared plus cosine squared is 1. This is one of the most important identity in trig, and we call it the Pythagorean identity, and we'll see why later on this works out. So from here, let's say they give me sine. How am I going to find cosine? Well, I can solve for cosine, which is 1 minus sine from the box identity. And then cosine by the square root properties plus or minus the square root of 1 minus sine squared theta. So if I want to apply it to this given problem, they give me sine theta negative 5 over 13. So I'm going to go cosecant theta plus or minus 1 minus negative 5 over 13 squared. Note something, I'm working in quadrant 3. So theta is located in quadrant 3. I always like to shape the quadrant so I don't forget it. Note in that quadrant cosine is negative, so I'm going to choose only the negative sign. Squaring 5 is 25 over 169. Keep this the same. Combine the fractions. 169 minus 25. Negative the square root of 144 over 169. That gives us negative 12 over 13. As soon as you find sine and cosine, the rest are easy to find. We can use what we learned today. Tangent is sine theta over cosine theta. Sine was given as negative 5 over 13. This is negative 12 over 13. So 13 cancels, so it gives us 5 over 12. Cotan theta is the reciprocal of this. Just flip it. Secant theta is the reciprocal of cosine. So cosine is negative 12 over 13, so it becomes negative 13 over 12. And cosecant theta is the reciprocal of sine. Sine was negative 5 over 13, becomes negative 13 over 5. Notice we are in the, again, third quadrant. In third quadrant, only cosine and sine are positive. Tangent and cotangent are positive. So this is tangent, it's positive. Cotan is positive. And the rest, notice negative, negative, negative. And the given one was negative. This is a good way to test it out. Back to the identity, sine squared theta plus cosine squared theta equals 1. If we divide everything by cosine square, so divide everything by cosine square theta, assuming it's not 0, what do we get? We get sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equals 1 over cosine squared theta. Sine over cosine is tangent, so that gives us tangent squared theta. Cosine squared over cosine squared is 1 equals 1 over cosine is secant. So that gives me another identity. 1 plus tangent square is secant square. What about, again, if we take the same identity from before, and instead of dividing by cosine square, I'm going to divide each one by sine square. So I'm going to divide this by sine squared theta, this by sine squared theta, and this by sine squared theta. What are we going to get? This is 1, this is cotangent square, and this is cosecant square. So that gives us another identity. So far we have 3 of them. Let's summarize them here. Sine squared theta plus cosine squared theta is 1. 1 plus tangent squared theta is secant squared theta. 1 plus cotan squared theta is cosecant squared theta. How do we apply them? Just to get used to them. Find the exact value. Of course, without using calculator. First example, tangent 59 degrees minus sine 59 degrees over cosine 59. Well, the first thing, what can I do with that fraction? This, nothing can be done for tangent, but sine over cosine is tangent. So what does that give us? Tangent minus itself, so that's 0. So we don't have to find the exact value for each one of them, but we can find the value of the entire expression. What about sine square pi over 11 plus cosine square pi over 11? Well, from the main identity, sine square alpha or theta plus cosine square theta is always 1. So no matter what theta is here. So that's why this is simply 1. Secant square 15 degrees minus tangent square 15 degrees. We don't have an identity secant square minus tan, but let's go back to those three. I see the middle one, this one here, has to deal with tangent and secant. So we know that 1 plus tangent square, so on the side 1 plus tangent square theta is secant square theta. So if I subtract tangent square on both sides, I get 1 equals secant square theta minus tangent square theta. So the answer to this one is 1. Another one, cosine square pi over 18 plus 1 over cosecant square pi over 18. Let's keep the first one the same. Always look at the fractions and see if you can rewrite it in a simpler way. What's 1 over cosecant? Well, 1 over cosecant theta is sine theta. So 1 over cosecant square is sine square. So 1 over cosecant square is sine square. So this means it's sine square pi over 18. So sine square pi over 18 plus cosine square pi over 18 is 1. So we were able to find what the value of each expression without knowing what the value of each trig function of those angles. Now we need to introduce more properties, but before we do this, let's recall from before. If f of negative x, a function f of negative x equals f of x, this tells us that f is even function and symmetric about the y-axis. If f of negative x equals negative f of x, then f is an odd function and symmetric about the origin. This was applied in algebra. We can apply the same thing in trigonometry. So we say properties, more properties here. We call them even odd properties. Even odd properties. So what do we have in here? Even odd. If theta is an acute angle, we have sine negative theta. We're going to find what that is. Cosine negative theta, tan negative theta, cotan negative theta, secant negative theta, cosecant negative theta. So how are we going to find these out? This is what we do. Remember from before, from the previous lesson, this is the positive direction, that's the negative direction. If you're traveling negative theta, which is an acute angle, so it means we are in the fourth quadrant. First thing, all these are gonna come, you can drop the negative sign. We can drop the negative sign. Now, after dropping the negative sign, what we have, we are working in the fourth quadrant. In the fourth quadrant, we have cosine theta and secant theta. Those are the only positive ones. Only positive ones. So cosine positive and secant positive. This means the rest are negative. That's an easy way to memorize it. Easy way to memorize. This tells us from here that this is an odd function. This tells us it's even, and this is even. The rest are odd functions. That's why we call them even odd functions, because some of them they satisfy the even function condition and some satisfy the odd one. Let's see how to apply them if we are asked to find the value of sine negative 30 degrees. Well, sine negative theta, what is it? It's negative sine theta, so it's negative sine theta 30 degrees. And from the previous section, if you look back, sine 30 was 1/2. Sine 30 is 1/2. What about tangent negative pi? Again, tangent is an odd function, so we can take the negative out, negative tangent pi. And that gives us negative. Tangent pi is 0, so that's simply 0. Another one, cosine negative 45 degrees. Cosine negative theta is cosine theta, so you can drop the negative sign. And from the previous section, we proved that this is square root of 2 over 2. Square root of 2 over 2. What other things we need to learn here? What kind of other properties we have? Let's look at if we pick a point on the unit circle or any circle. This is theta. So OP is the terminal side of theta. That's the terminal side. Now what happens if I go again back to the origin and then I go around and land back again at the same side? This means I traveled not just theta, but I added another 360. And 360 is the same as 2 pi. So keep that in mind. 2 pi radians. What about if I do it again? I'm going to travel 4 pi or negative 2 pi. Like if you go the opposite direction. Or theta minus 4 pi. And this can go on and on. So the terminal side will be the same to all of them. The terminal side. So they all terminate at the same point B. So what does that tell us? If I want to find sine theta plus 2 pi, 2 pi is like the same as sine theta, like these all are the same. So that's going to be the same as sine theta. Same thing for cosine. Cosine theta plus 2 pi is going to be cosine theta. But wait, what about 4 pi, 6 pi, negative 2 pi? Well, what we can do here, instead of just writing 2 pi, we can write 2k pi. 2k pi, where k is an integer. Because that will generate all the angles for us, the theta plus 2 pi, theta plus 4 pi, and so on and so forth. So that motivates us to introduce a definition here. The definition said a function, call it f, is said to be periodic if there is a positive number p such that whenever theta is in the domain of f, so is theta plus b, and f of theta plus b is f of theta. So this p, the p value can change. As you noticed earlier, we had 2 pi, 4 pi, 6 pi, 8 pi, or negative 2 pi. So what we do here, we say the smallest possible positive value of p is the period of f. Is the period of f. So we can summarize the periodic, we call them periodic properties. What are the periodic properties? Well, we start with sine theta plus 2 pi. Sine, we told you earlier, that's simply sine theta. And that's cosine theta. This tells me that 2 pi is the period of both sine and cosine. Same thing applies for secant and cosecant because they are simply reciprocals. Theta plus 2 pi plus 2 pi, that's secant theta, that's cosecant theta. So the period here, 2 pi for all these functions. But for tangent cotangent, the period is only pi, so it's theta plus pi, cotan theta plus pi. That's tangent theta, cotan theta. So that's pi is the period. The question is, how do we use those? Well, let's say we are asked to find the value of sine 25 pi over 4. If you convert that to degrees, that will be a huge number. Instead, we can do this in a slightly different way, thinking about what is the closest even multiple of 4 to 25. The closest even multiple of 4 to 25. That's 24, right? 24 pi. So you can rewrite that as 24 pi plus pi over 4. And using the algebraic property that we are allowed to break this down into two fractions, 24 pi over 4 plus pi over 4. That gives us sine 6 pi plus pi over 4. But 6 pi, again, it takes us back to 0, right? 2 pi, 4 pi, 6 pi. So it's kind of like 0. So that gives us sine pi over 4. Pi over 4 is 45 degrees. And from the previous lesson, we proved that this is square root of 2 over 2. So this is one application to that. What about if they ask us to find cosine 7 pi? Again, if you think about 7 pi, any odd number of pi will land exactly at pi, because that's pi. If you move 2 more pi, you go back here. So pi plus 2 pi is 3 pi. So any odd number of pi will land exactly at pi. You can think about it this way, or you can rewrite this as 6 pi plus pi, because any even number of pi is 0. So that gives us cosine pi. And we know from the previous section, this is -1. So we can write here on the side, any even number of pi is 0. Any odd number of pi is pi. Let's apply it more. What about sine 70 degrees over cosine -430 degrees plus tangent -70 degrees? How do we apply it here? For the 70 here, nothing I can do. For this one, I see a negative sign. I can use even odd identities and find out that this is negative tangent 70 degrees. The top one, nothing can be done. Cosine, what about -430 degrees? -430 degrees. What we do here usually, we either add or subtract multiples of 2 pi. Multiples of 2 pi, because 2 pi is 0. 2 pi means it's 2 pi always 360 degrees. So if you add 360 degrees to this, that's going to give us -70 degrees. So I'm gonna substitute this with negative 70 degrees, because remember, adding 360 is gonna land at the same terminal side. It's the same angle. So that's why we can replace the negative 430 degrees with negative 70. Again, using the even odd identities, cosine negative 70 is cosine 70. And keep this the same. Sine over cosine is tangent. Minus tangent 70 degrees. So that would give us 0. Other applications, let's say if cosine alpha is 0.3, find the value of, let's say, 3 cosine alpha minus 4 cosine alpha plus 4 pi plus 6 cosine 2 pi plus alpha. This might look difficult, but if you look at these numbers, 4 pi, 2 pi, other stuff, before we substitute anything in, let's simplify. Remember, even number of pi is 0, so you can really drop that out. Another even number of pi, that's a 0. So those called like terms. So if you combine them, 6 plus 3, 9, minus 4, 5. 5 cosine alpha. So what we're going to do is we're going to just multiply the 5 by 0.3, because that's what cosine alpha is given as, and this would give us 1.5. One other application, find the value of cosine 1 degree plus cosine 2 degrees, no calculators are allowed, cosine 3 degrees plus all the way cosine to 358 degrees, cosine 359 degrees. This can be a challenging problem to most students. What am I going to start? How am I going to use all these properties we learned today? Well, let's start on the right hand side. Let's keep this the same. What I can do on the right hand side, I'm going to rewrite some of these functions on the right hand side as, instead of 358, that this looks very close to 360. So I can write as 360 degrees minus 2. And I can write this as 360 degrees minus 3. Yeah, minus 1. Now let's keep this the same. Even if I add another one, it's going to stay the same. For this kind of one, the 360 is simply 0. So that leaves negative 1. But with the even odd identities, we know cosine negative alpha is cosine alpha. So now, how many terms we had in the original problem? From 1 to 359. We had 359 terms. So the middle term that we can't see. So imagine this is a 360. So the middle term here is supposed to be cosine 180. 360 divided by 2, that's 180. That's the middle term. And if we need to see what happens here, in the middle we have cosine 180 degrees. Plus. So notice how these match. So we can pair them into 2 cosine 1 degrees, 2 cosine 2 degrees. And this can keep going on and on. So the one right before this and here, that would be 2 cosine 179 degrees. And then we're going to keep cosine 180 as is. And if you like to find more terms, the one right before this, it would be 2 cosine 178 degrees. It's not done yet. I don't know what cosine 1 is. I don't know what cosine 2 is, or 179 without a calculator. So what we can do, notice two cosine 178 is 180 minus 2. This is 180 minus 1. And this stays the same. Stays the same. The 180 minus theta. So 180 minus theta. This is this 180 minus. If you like to see where that is located, 180 minus theta. So you travel in the opposite direction. We are in the second quadrant. So in the second quadrant, cosine is negative. So that becomes negative 2 cosine 2 minus 2 cosine 1 plus cosine 180. Notice how this cancels this. This cancels this. And all the middle ones will cancel each other. So the only thing left is cosine 180 degrees, which we already know from the previous section was negative 1. From the previous section is negative 1. So again, this section introduced a lot of properties of trigonometric functions with some identities. The properties, the first thing we wanted to know where each function is going to be positive and in which quadrant, and in which quadrant each one is negative. This is very important. Then we introduced the reciprocal identities, quotient identities. We're going to be using this throughout the semester. We're going to always refer back to them, those identities. And then we introduced the even-odd identities. Even-odd identities down there, here. We spoke a little bit about periodic functions, that tangent and cotan with period pi, but sine and cosine, secant, cosecant, they have period 2 pi. We introduced more properties, or we call them identities. The sine squared theta plus sine squared theta, sine squared plus cosine squared is 1. And from that one we got 2 more identities that we use them. That's what this section is about.